Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting-edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Timothy Robertson, who has a bachelor's in physics from Princeton and a Ph.D. in physics from UC Berkeley. How are you doing today?
Great. So nice to be here with you, Rohan.
Yeah, thanks for joining me. So to start off with, I wanted to ask what made you choose physics for college?
So it was a bit of a roundabout path, actually. When I was in high school, I grew up in a family of doctors, and my parents sort of expected me to go off to college and become a doctor. And my big act of rebellion was when I went off, I said, no, I'm going to study mathematics. And so I went into Princeton intending to study mathematics, and I joined the math program there. And I was pretty good at mathematics. I had been like a state champion in the state of Indiana. And I got to Princeton and I was just blown away. There were people who were just in a completely different league, like, the difference between me as a top state mathematician, and they were like the best in the world. And so I went through that program. I went through the first 2 years of that program. And I decided that, I wasn't going to be a star in pure math. But I really liked physics and particularly experimental physics, because it has this aspect of building things and actually creating instruments. That's a lot of what I did. And what I really appealed to me is it explained the world to me as I started to take my physics course, which I did from the very beginning of my freshman year. I felt that the sort of techniques and the worldview that you learn in physics allowed me to look around and understand everything I saw around me. So I started doing research in a physics lab during the summer as I was taking my classes, and it kind of went from there.
Yeah. Uh, how'd you like the classes as a physics major?
Um, they were challenging, but I really enjoyed them. The physics class, the each class of students at Princeton is pretty small. I think my graduating class was 14 people, and pretty much everyone takes the same classes there. And so there was a lot of camaraderie. It's centered around problem sets, and so lots of late nights together in a library or in a room working on problem sets together, trying to solve the problems together. And it's really satisfying when you solve a problem, because one of the great things about especially math, and to a lesser extent physics, is you can know when you've got the right answer. You know when you've solved it. So there's that really satisfying bit when you hit that solution. Classes were great. For me, the independent research and working with professors in the labs was in many ways more important. I teamed up with a group that was developing telescopes, radio telescopes, to look at the cosmic background radiation, and started working on those, doing electronics. And we actually took one down to the South Pole. I got to go down to the South Pole as part of that research. I took a year off between my junior and senior year of college to do that, which was sort of a once in a lifetime type opportunity.
Yeah. No, I talked to someone last week. He's been at Antarctica 9 times as a researcher from UW-Madison.
Yeah, people get hooked on it. It's the freest place on Earth. Sort of the only rules are don't get killed and don't get anyone else killed. Apart from that, it truly is just a community hanging out there on the ice. And so it's an incredible place. And I'll always treasure that. That came directly out of my research experience, where I teamed up with this professor who would go down there every year, and he's probably been down there 20 times by now. I went down for 6 weeks and got to experience that.
Well, can you talk a little more depthly about that research?
Yeah, so this was in the early 90s and mid 90s. when there was a focus on what's called the cosmic background radiation, which is essentially the light that's between the stars. And it's in many ways the afterglow of the Big Bang. By studying it, we can understand the earliest origins of the universe, going back, 13, 14 billion years ago. And we were measuring very subtle differences in temperature of that background. So looking at one black point in the sky and another black point in the sky and measuring the temperature differences between them. And so these are tremendously sensitive instruments, because they need to take out all the external noise sources, like from the atmosphere. That's actually why you go to the South Pole, because there's very little water in the air at the South Pole. And so that makes the view through the atmosphere much better. The only better place you can go is to outer space, or perhaps to the Atacama Desert in Chile. I did a lot of work on electronics. And this is something I tell people who are at this stage of their lives. I really learned how to design circuits, how to make a circuit board, how to bring it up, how to test it, make it work. And I think it's really important that in college, you learn a craft of some kind. And by that, I mean, like, it's kind of crude to put it as a marketable skill, but something like you can do. For many people these days, that's in software one way or another. But I found when I came out of college that skill to be able to do electronics and build electronics made me really employable, because I could go in and I could apply for like an electrical engineering job. But then from there, I could do lots of other things. That gave me sort of the permissions to come into a company, have my core job, but then be able to expand out from there.
Yeah. So what made you want to get a PhD?
Well, so I didn't do it immediately after college. Many people go directly from college to graduate school. I actually founded a company out of Princeton with one of my professors, worked on it for a couple of years. It was sort of part of that whole dot-com boom. It was moderately successful, more for the times than anything that I did personally. And then decided if I wanted to be in tech, I should move out to Silicon Valley. So I proposed to my girlfriend. She said yes. Got in the car, drove cross country, moved to California. And I worked there for another couple of years in data storage, high-tech holographic data storage, working with a professor out of Stanford. It got to be 1999, 2000. Dot-com boom looked like it was about to become the dot-com bust. And I just wanted something more. I felt like there was more to learn. And so that's when I decided to apply to grad school. I ended up going to Berkeley. And in my undergraduate, I had done a lot of work on gravitation and cosmology, which is sort of one pillar of physics. And I felt like I didn't understand quantum mechanics. And so I wanted, for me, the best way to understand something is to try and work on it. So I went off to grad school to try and build a quantum computer. And that's what brought me to Berkeley and John Clark's lab.
Yeah. So what was your research about?
So in quantum computing, the fundamental unit is a qubit or quantum bit. And there are various ways of making these. Ours was using a superconducting loop of aluminum. And by configuring that, you can have the current flow clockwise around it or counterclockwise around it. And that's how you make your bit. And because it's a quantum system, you can actually have a superposition of clockwise and counterclockwise currents. But you have to keep the qubit very isolated from the external environment to do that. And even so, it's very sensitive. So we were trying to make some of the first versions of these and characterize their behavior. What that involved was microfabrication, so making these aluminum integrated circuits using electron beam evaporation. You have to cool these things down to near absolute zero, 50 millikelvin. And so you put them in a refrigerator, essentially, it's called, that allows you to cool down to that low. So I learned a lot about cryogenics. And then this is where my sort of electronics skills came in. I knew a lot about electronics, so I built the circuits to control those qubits and measure them. And then, we'd do experiments where we'd put them into various states and measure their properties.
Oh, can you dumb down a little bit? What exactly is a quantum computer compared to a normal computer?
That's a great question. And so in a conventional computer, bits are either ones or zeros. In a quantum computer, you take advantage of this fantastic quantum property that you can have both a 1 and a 0 simultaneously, which, it's hard to explain this, but one of the analogies is Schrodinger's cat. If you read about that sort of illustrative situation where you have a cat that's both dead and alive, which is kind of the absurd real extent of it, because it doesn't actually happen at the large scale, but it does happen at the small, micro, and nano scale. And if you think of a computer in some ways as an oracle, you ask it, is the answer 1? Is the answer 2? Is the answer 3? And eventually it gives you it says, yes, that's the answer. With a quantum computer, you can ask all those questions simultaneously because you can put these bits in this superposition. And that is useful for cracking codes, it turns out, for breaking cryptography, which is why there was so much interest and money going into it. With this sort of technology, all of our encryption, like when you do an SSL connection on the web, is based on an underlying mathematical fact that it's hard to factor a big number into its primes. So you make a really big number, you generate 2 really big primes, you multiply them together, and then it's very hard to undo that operation to figure out what 2 primes you multiplied together after the fact with a conventional computer. With a quantum computer, that becomes much easier. And so that's why we were doing this research. It was funded by the various government agencies that have interest in that, because they want to know if they're say the nuclear codes that they send to a national laboratory are protected by the encryption. And so we were working on that. It's a very theoretical problem. Here we are, probably 25 years later, and it's still a pretty theoretical problem. No one's quite exploited the technology to actually be able to solve quantum problems better than classical computers, but it's generated a ton of really interesting science along the way.
Yeah. Oh, so what was your first job out of your PhD?
So when I finished my PhD, I had worked in high tech between my undergrad and graduate work. And I decided that I wanted to work in medicine one way or another. Going back to the beginning, my parents wanted me to be a doctor. Well, coming out of all this, I said, medicine is really, it's interesting because the problems are really challenging. You can make a huge difference. And when you do make a difference, it makes a really concrete improvement in people's lives, health, and well-being. So I joined a company called Proteus Biomedical that was developing a new type of cardiac pacemaker. So this is the medical devices field, Silicon Valley venture-funded startup. And that was my first sort of exposure to that world, which was just fantastic. They took a leap of faith on me because I didn't have any experience. But I got in and I just sort of started becoming a hacker and pushing the technology in various ways. I had a number of inventions there and actually took the company in a new direction.
Yeah. What was your favorite part about that job?
Well, I was in that job for like 9 or 10 years. So, I mean, overall, it was the growth. I came out of that job a very different person than I went into it. Going in, I was a very technically focused person who, based on my education and my talents, I could create technology sort of single-handedly. We created some products, and I got to follow those all the way through and expand my skill set, going from being essentially a scientist and engineer to a technical manager to a product manager to an executive in a company. And so I came out of that, that actually set me up to start founding companies because I had kind of seen the whole thing through there. So it was just a tremendous growth experience over a decade of my life. I got to go all around the world. I worked with pharma companies in Europe and in Asia. And I got to get exposed to the venture ecosystem and really start to understand how that works. I got to present to the board and work with some really, incredible people there. And all the time working on cutting edge tech. So it was just a fantastic experience all around.
So what'd you move on to after this job?
So I had always wanted to found companies of my own, but I felt like I needed more experience to do that, and I wasn't quite ready for it. But after that experience at Proteus, I felt like I was ready. And so I teamed up with one of my neighbors, actually. We had worked together on some sort of local city governance issues, who was also an entrepreneur, and he wanted to found a company. And so we sat around, in the evenings, bouncing ideas back and forth on what we should do. And we came up with this idea of an automated vivarium. A vivarium being a place where you keep mice and other animals for doing research on, drug development and other things. And so, I was the CEO of that. He was the CTO of it. It was called Mousera. We later renamed it Viam. And that was about a 5-year ride of going from nothing. We built the first prototypes in our basement to launching the product and eventually selling that company.
Yeah. Did you like founding your own company and having a job like that?
I do. It's complicated though. It's really hard work. It's very stressful, and particularly when I founded that first company, I wasn't well equipped to deal with the stress. Since that's something that I've learned a lot about and how to manage that much more. But in terms of learning ability, in terms of having a degree of autonomy and being able to really choose your own course and getting to work with the great people. One of the best things about founding a company is you get to pick who you work with. It's fantastic. And these days I don't work any other way. I like to be in a position where I can really drive the decisions and take things in the direction that I think is best.
Yeah. Uh, when you're doing that, how many hours were you having to put in?
It's kind of a funny question in some ways because you're always working, even when you're, having dinner, you're carrying those things along with you. And particularly as a startup CEO, you have to always be on, like you have to be ready to respond to things 24 hours a day. And that's where the stress comes in. It doesn't mean, you're sitting at your computer doing things all the time, but you never even really get to go on vacation. You go away and you still need to be checking your email. You still need to be responsive because there's no one else who can back you up. So it's more than like an hours a day type job. It really is a lifestyle, and you have to be prepared to buy into that lifestyle.
Yeah. So once you sold your company, what'd you start doing?
So I had actually left before selling the company. The VCs had brought in a new CEO to sort of like scale the company, and they sold it. And so I started, well, first of all, I needed to take just sort of a year to get myself put back together because, again, of that stress. My body was all kind of twisted up and mixed up. I had lots of aches and pains from the stress. And so I started a pretty intensive physical regimen with sort of an intensive yoga practice at the center of it. I had to reconnect with my family in a lot of ways because I had put so much into my startup that my kids were growing up, and I wasn't giving them the time that they deserved. I had to fix up my house, the sort of things that you neglect when you're working in a high pressure startup. And then I started just looking for things that came along. So a friend of mine asked me if I could investigate a certain business proposition that he had in mind. So I did that. I started advising entrepreneurs, sharing my experiences as a first-time startup CEO with them and helping them along their way. And from there, my job has become, I would say, much less well-defined. I do a lot of different things. I have one, sort of primary activity that my company TLR Ventures does, where we're developing a new innovation model But it's really a mix. I've founded several other companies since then. I stay involved in those. Um, and I try and bring my experience and my perspective to moving multiple ventures forward.
Yeah. Can you talk a little more specifically about what these ventures are?
Sure. So the first one, this was a friend of mine who had actually worked for me at Proteus, and I'll say one of my proudest accomplishments is that five people who I've hired or trained up have gone on to become CEOs of their own companies. So this person, he had a company around AI, centered around sort of a Bitcoin approach to that, a blockchain approach to that. And he had an idea to apply it to livestock. And so I looked into it. I sort of explored the space. I built the first prototypes. I started bringing on the first customers and advisors, got it to a certain point, and then we decided we found a company called Precision Livestock Technologies, which that I then handed over to a friend to become the CEO and run that. I remain on as the executive chairman of that. What we do is we put cameras up on poles looking down at cattle and livestock. We monitor how they eat, their health and well-being, to try and optimize the production. And so that company has been going for several years now. It's commercial. It's growing. Let's see. In that time, I did a stint as a interim chief technology officer for a medical device company. They had sort of been upended by the COVID pandemic and by their previous CTO leaving. This was an entrepreneur I had been advising. So they asked me if I'd come on and help them through this. So I helped them in various ways, sort of go to the next level and weather out the COVID storm, and help them find a long-term CTO. And then, the thing that I'm mostly involved in now comes back to my experience with mice and at Viam and Mousera. I'm working on developing for a major research lab a next generation digital system to accelerate the development of drugs and preclinical research.
Yeah. Can you talk a little bit more about that?
Sure. Drug development is a complex multi-step process that ranges from, ideas about how we might affect a disease and make it better at sort of the molecular and cellular level, all the way through to when we eventually test out drugs in the clinic on people to determine if they're safe and effective. And the step right before you take them into the clinic is called the preclinical stage. And this is where you test them on animals, typically mice, sometimes rats, sometimes other species, to determine if they're safe and effective. And I was struck by the way those experiments are done. They're often, they rely on manual observations, like you might have a model of ALS, where a mouse displays increasing paralysis, and you want to give a drug and try and reverse that process. The way that's assessed is by a person looking in the cage and say scoring on a 4-point scale, how sick is this mouse? And of course you give the drug and you want to reverse that. Well, what we're doing is using cameras to monitor the mice continuously, actually measuring how they move using computer vision and AI techniques. And then we can quantitatively say, is the mouse healthier? Is the drug working? And so this allows us to take a lot of that subjectivity out. It allows us to monitor the animals continuously 24/7, whereas a person can only look in the cage, for a few seconds, a couple times a week. And it allows us to see things that we otherwise wouldn't see. And so the idea is that better drugs then go into people, that they're more likely to succeed in those clinical trials.
And what stage is this company in? Are those sensors being used already?
They are. They're being used within a small group of pharma companies in an organization called the Digital Invivo Alliance that I helped found. And they'll be commercialized in the next few months. So that's really exciting for me to see this work go all the way through. And I think it's going to have a really big impact on preclinical biological research.
Yeah. For my last question, I wanted to ask what advice you'd give someone who's still in high school or early in college who wants to go down a similar career path as you.
Hmm. So, one thing I touched on, which is find a craft, find something, a skill that you can do where you can just do work and get better and better at that. Keep working at it, train on it like an athlete, because many things, there's a talent component, but oftentimes the talent component is outweighed by just focusing on it. And a big part of focusing is just showing up and doing it again and again. Um, I think also find what you're good at and play into that. And oftentimes, what you're good at aligns with what you enjoy. And if those don't align, ask yourself why don't they align? And try and find, maybe it's something adjacent to those. Um, about college, I would say it's hard to appreciate it when you're there, but those 4 years of your life will be the most incredible years in retrospect. And there's so much going on. You've got the academics, you've got the social dynamics, you've got a whole new group of people you're working and with and ideas you're being exposed to. Just suck it all up and make the most of it. Because it's really, for me, they were the greatest years of my life. And the friends that I made in college are still my best friends today.
All right, then. Thank you for meeting with me.
Pleasure, Rohan. I really enjoyed this, and it's a pleasure to speak with you.